In this video, I'll show you how to create some simple unit tests for your C# projects. First, what is a unit test? If you're not familiar with them, a unit test is just a small separate function outside of your normal program that tests the functions inside your program. For example, here I have a very simple program with one class called math functions and one function called add numbers. Takes in two integers, adds them up, and returns that value. So if we pass in a 2 and a 4 for the add numbers functions, we expect a 6 to come back. A unit test will call this add numbers function, passing in a 2 and a 4, and verifying that we do get a 6 back. Now this is a very small, simple function. We really don't need to do a whole lot of testing here. In fact, it probably doesn't need to be a function. But in our real programs, our functions will probably be more complex. They'll do a lot more inside of them. They'll have branches. If something is true, do some set of calculations. If it's false, do a different set of calculations. So we want to make sure that whatever path we follow through that code for the function, we get the correct result back. And that's what the unit test will let us do. They're also nice to have in case we change a program in the future, or even as we're building the program. This way, if I went into this add numbers function and made a change that broke this, when I run the unit test, it will let me know right away something broke in the add numbers function. So I can go and fix it before I commit the code to my source code repository and potentially deploy it to production or give it to users. They're a nice safety check that runs very quickly and eliminates the need for someone to manually enter in sets of numbers and checking them in the UI. Now I'll show you how to add some unit tests to an existing application. In this case, I have a very small demo application. I have a console project here, demo app. It's in .NET 6, but all these principles work for any version of .NET or .NET Framework. I have a demo app.engine, which is a class library project, and our unit tests are always going to be against a class library. There are some other types of tests we do if we want to automate testing through the UI. So for the solution, to add a unit test project, you would right-click on Solution, click Add New Project, and I have this selected for C#. I'll type in unit test up here in the template search, and we have several projects. We have unit test project .NET Framework, which is the one you would use if you're working with .NET Framework. But for .NET Core and .NET 5 and 6, we have several different projects. We have this MS Test project that says it works on .NET Core, which also means it works on .NET 5 and 6. We have XUnit test project for .NET Core, and we have NUnit test project for .NET Core. NUnit, XUnit, and MS Test are all different unit testing libraries. They all do basically the same thing, just in slightly different ways. You can pick any one of these and you'll be able to write good unit test. Personally, I prefer XUnit unit test projects. XUnit seems to be a little bit more active and up to date. But again, any one of these will be good for creating your project. I already created my unit test project here, test.demoapp.engine, which points out another thing. A lot of times programmers like to have their unit test project somehow mirror the name of the class library project they're testing. In my case, I have demoapp.engine as the class library project, so I named the unit test project for this class library to test.demoapp.engine. Now I know all of the unit tests for demoapp.engine will be in this test.demoapp.engine project. This makes it a little bit easier to keep track of your unit test when you start building larger solutions. Once you create your test project, you need to set a project reference to the class library you're going to test, because this test project needs to work with the classes and the functions in the other project. So you would right-click on Dependencies, select Add Project Reference, and then check the class library project you want to work with. I've already checked the demo app.engine one, since that's the one I'm going to test in this test project. Next, you create your class for your unit test. I've created this one called Test Math Functions. Again, I like to mirror the name of the class I'm testing. And at the top of your test class, you'll have to add a using directive to point to whatever namespace your classes you're testing live in. In this case, I'm testing math functions, which is in the demo app.engine namespace. So my test class needs to have a using demo app.engine so it can see these math functions. Then you start creating some public functions, they're public void functions, that will have code in here to test out calling your other class library functions and classes. For all three types of unit test libraries, mstest, xunit, and nunit, you need to put some sort of attribute before the function so your test running code knows which functions are unit test and which functions are just regular functions. For xunit, the attribute you want to add is fact. For mstest and nunit, I believe the attribute you would use would be test. Here I'm going to test the add numbers function, so I just name my function test_add_numbers. This way, if the unit test fails and the tool that's running it reports the test that does fail, I'll have an idea of what it was trying to do. Inside the function, you want to do something they usually call AAA, which is arrange, act, and then assert. So you arrange any classes you need, you instantiate objects, initialize them with whatever values you need. Then you do some action, you're going to call the function that you want to test, and then you do your assertion. You check to make sure that the function did the correct thing. In this case, I don't need to arrange anything. This is a static class with a static function that doesn't maintain any state or do anything else, so there is no arrange. I can just directly call the act. So I'm going to call mathfunctions.addNumbers to 4, and I'll get the result back from it. Then on line 12, I have my assertion. I want to assert that this value here, the 6, is the value that I got back for the result. This is something that should be true. If this is true, then that means my code is working. So now I can go to the top of Visual Studio, click on the Test menu option, and click on Run All Test. And this will run everything that has this fact attribute and let me know whether it passed or not. Here, if I expand, we'll see that in my test math functions, my test_addNumbers function is a green check mark. So that means the assertion was true. The result that we got back equaled 6. If I change this to 7, but still passed in a 2 and a 4, and I ran my test, now I get a red X, and it says assert equal failure. And if we expand this a little bit, we can see we expected a 7, but we actually got a 6. That's telling us our assert here, we expected the 7, but result was 6. And this is always a good idea to do with your unit test. Give it an assertion that you know will fail, because it is possible that you write some code in your unit test function that would be true all the time. So I like to do something like this, do my assertion, make sure it fails, and that it notifies me it failed, and then go in and put the correct result, run the test, and make sure that they pass. Another thing to notice is you can potentially have something wrong in your function and still have your test pass. For example, if I went into this function and just said return 6, I can run this test and it will pass because it's saying I'm passing these two numbers and the result I expect back is a 6. So let's run these tests, and we see it's still green. But if I add in another assertion, in this case I'm going to assert that the result of calling math function .add numbers with a 3 and a 4 should be a 7, and I still leave this hard-coded return 6, when I run my test, I'll see that test add numbers fails, because on line 13 I expected a 7 and I got a 6. And that's this line here with the assertion. But if I go back here, change this to the correct code, and rerun my test, they're green now, because both assertions are true. A very important thing to notice is that our math add numbers function does not call any external resources. Here it's just doing some calculations and returning a result. It's not going out to a database and getting some data. It's not calling an API on the web. It's not writing a file to disk or reading a file from disk. This is all just internal code. It kind of doesn't leave the memory of our program. You can write unit tests for code that reaches out to other things, web services, database, file system. However, you need to do something there. Generally, we do mocking. I'll show that in another video, but in this video, I just wanted to do some basic unit test, because the next thing I'll do is show how we can integrate this with GitHub, so our unit tests will be run every time we commit code. And this way, if any of our unit tests fails, then GitHub can say, I'm not going to accept this change. Something is wrong, you have to fix your code before you can actually commit it. And this is extremely useful for large systems and when you're working with other developers. People are making a lot of changes and they may not realize that one of their changes breaks some expected behavior in the function for another place in the code. But that's it for the simple setup of unit test for a C# program. If you have any questions, as always, please leave a comment below the video or on the support page, and I will try to answer as soon as possible.